All right, class, in this video, we want to continue our series on system of equations. We want to look specifically at how to identify the number of solutions in a given system. Now, you'll recall we've worked through examples where they have one specific solution, just one solution, that's it, and that's where the two lines cross. We've looked at no solution, which means they're parallel and they never cross, so there is no solution. And then we have seen those that lie on top of one another, and they have infinite number of solutions. So let's take that and just look at a few simple graphs. Here in this graph here, we see that we have these two lines that are parallel. They're never going to cross, and we would call this a no solution. There's never a point when either this graph or this graph cross, and that's why there's no solution. There's no intersecting point. When we come to the second graph, we see that we have two lines, and they do absolutely cross, and they cross right there at point 1, 1. All right, and so that would be the solution, and we would say that that system has one solution. That is only this point right here where the two lines of differing slopes cross. All right. Now they have differing slopes, but it's also important to note that they have different y-intercepts. So they can have different y-intercepts, have a different slope, they're eventually going to cross and have one solution. Now in this example, it looks like just one line, but in a system, this would be two lines and they're on top of one another. It's basically the same line, and so again, any point on this line, if I pick a point anywhere on this line, plug it into either equation, which is the same equation, of course, it's going to work. Anything is going to work. So there are infinitely many solutions. Over here I have just one. In this case I have many. I have infinite. All right. Now in this last one, this is also an example of one solution. The only difference between this graph and this graph is that in this fourth one, they have the same y-intercept. So they have the same b value. And that's okay. They have the same y-intercept or b value, but they have differing slopes. And so that's not going to be an infinite. It's going to be a one solution. This spot is the only place that satisfies the given system of equations. All right, now with all of that said, let's look at some examples and practice problems. All right, on these examples and practice problems, we're actually not going to take time to graph them. We just want to assess what we actually see in the problem. First thing we want to look at is their slope. And we want to ask ourselves a simple question. Do they have the same slope? It's a good question. Do they have the same slope? The answer is no. What about the same b? No, they don't. So they have differing slopes and differing y-intercepts. That's an example of one solution. That is a one solution problem. Now if we scroll back up, here, differing y-intercepts, differing slopes, and we can see that graph, that is a one solution problem. Differing slopes, differing y-intercepts, and it is a one solution problem. So go ahead and pause the video and try the practice problem. All right, now that you've done that, let's assess. It might be helpful to write this differently. Let's write it in the form of y equals mx plus b. We know that that's a plus 0. So do they have the same slope? Do they have the same slope? No, they don't. This has a -1 slope. This has a 3 slope. Do they have the same y-intercept? No. This has at the origin at 0, and this is at 5. Differing y-intercepts, differing slopes, and that is a one solution. Let's go down here to our next example. We're going to need to rewrite this in the form of y equals mx plus b. So we're going to divide both sides by 3 and get y is equal to 2/3 x plus 5. And our other equation in this proposed system is y equals 2/3 x plus 3. So now look carefully. Do they have the same slope? Yes, they do. That means these are parallel lines. So they're going to be running in the exact same direction. right next to one another. So now the question then becomes, okay, well, what about the y-intercepts? This is a +3, and that's a +5. And so what's going to happen is, if we scroll back up, which of these would it line up with? Which of these would it line up with? And it is this one. They're parallel, but they have different y-intercepts, and that means it is a no solution. So this is a no solution. They're parallel to one another, like train tracks, but they start at different places on the y-intercept, y-axis. They will never cross one another. So go ahead and pause the video and try to work out this practice problem. All right, so let's look at this one. And again, first thing we need to do is to rewrite this in the form of y equals mx plus b. So now I have this problem with this line, and we know that's +0. You don't have to show that. But here again, we see what's happening. They have the exact same slope. That means they're parallel, but they have different y-intercepts. That means they are never going to cross. This is a no solution. All right, so let's keep rolling. Let's look at some other examples here. What about y equals 3/4 x and 3x minus 4y equals 0? All right, this one I can work with. This equation needs to be rewritten in the form of y equals mx plus b. So that's going to be y is equal to 3/4 x. All right, look at that. They are exactly the same. Exactly the same. So if I were to graph those, I'm going to start, I told you I wasn't going to graph, but I'm going to go ahead and do it. Up 3/4, it's going to look something like that. Both of them will. So this is infinite solutions. Infinite solutions, because each line is the exact same. And so any point on that line that I insert in for x and y, it's going to work. Any point on that line. So go ahead and pause the video. Try the practice problem. Now, as you look at these two, they're going to both need to be rewritten. Both of them. So this is going to be y is equal to 2x plus 8. So there's my first equation. This one, I'm going to need to divide everything by 2, and that's going to give me y is equal to 2x plus 8. Again, they're the exact same. So any point on the line that I insert in, I substitute in, it's going to work. And that's going to be infinite many solutions. All right, let's scroll up here. And let's look at this last example problem. Here, they don't immediately give us the line. They give us points on a line. So we've got a line 1 and a line 2. Now you'll remember, we've been working on this in class. We have to use the slope formula, which is y2 minus y1 over x2 minus x1. And so let's let this be 1 and this column be 2. So that means y2 in the line 1 is going to be 2. That's going to be minus 4. 3 minus 0. That's going to be negative 2 over 3. So there's my slope, negative 2/3 for line 1. So if I were to start off with y equals mx plus b, I can insert my slope and get y is equal to negative 2/3 x plus b. Now we've been doing some of this, so hopefully it looks somewhat familiar. What do I do next? I pick one of my points. Let's pick point number 1. I'm going to substitute 4 in for my y. Negative 2/3 times 0. That 0, this 0 is that 0. And this is my x value. So I substitute it in for x. This 4 is the 4 right there. All right. And that is going to be plus b. So I have reduced an equation that has one equation with 4 unknowns. I solved for the slope. That replaced one unknown. I used this coordinate on the line. So there's my 4 and my 0. That's my y and my x. I substituted those in. So now I'm down to just one unknown, and that is going to be b equals 4. And so now I have a new equation now. Watch this. We can do y is equal to negative 2/3. That looks like a 4. I am going to erase that and just start over. All right, so y is equal to negative 2/3 x plus 4. So I've got an equation here. Now I've got an actual equation of the line. Now I have to do the same thing for the next one. So that's going to be negative 7 plus 3 over 9 minus 3, which is negative 4, over 6, that's negative 2/3. I'm seeing a similar slope here. So that's y is equal to negative 2/3 x plus b. Let's use that first point, so that's going to be negative 3 is equal to negative 2/3 times 3 plus b. All right, so if we want to simplify this just a little, that's going to be negative 3. Those 3's will cancel, and I'm going to have equals negative 2 plus b, or b is equal to negative 1. b is equal to negative 1. I'm going to add 2 to both sides, and that means I'm going to have y is equal to negative 2/3 x minus 1. Now, I can solve these by graphing. That's the one method that I've taught you, but right now we can also just look at these. These are parallel lines, aren't they? These are parallel lines. My slope is negative 2/3. This slope is negative 2/3. They're parallel, but they have differing y-intercepts, and so that is an example of no solution. All right, we don't have a lot of space left for this last practice problem, but I want to ask you to pause the video and try this practice problem. All right, now that you've done that, let's just start working. It's going to be 2 minus 6 over 2 minus 0, which is negative 4 over 2, or negative 2. So I'm going to have y is equal to negative 2x plus b. Let's insert our first point. So that's going to be 6 equals negative 2 times 0 plus b. So b is going to be 6. What's my first equation? Y is equal to negative 2x plus 6. That's going to be the equation of the line for line number 1. For the second one, we are going to have, well, look at that. All right, just had a total mental lapse there. I thought I had messed up, but let's keep rolling. All right, line number 2 now. So this is going to be line number 1. And let's do line number 2. We're going to have 4 plus 8. Now that's 4 minus a negative 8, so that's 4 plus 8. 3 plus 1 is equal to 12 over 4, or 3. So we're going to have y is equal to 3x plus b. Let's use our first point, so that's going to be a negative 8 is equal to 3 times negative 1 plus b. That's going to be negative 3, so I have to add 3 to both sides, which is going to be b equals negative 5. So what's my other equation? Y is equal to 3x minus 5. Y equals 3x minus 5. And so the question is, is this a no solution, a one solution, an infinite solution? Well, let's look at it. Are my slopes the same? No, my slopes are different. Slopes are different. Y-intercepts, they are also different. This is going to be a one solution problem. At some point, these two are going to cross. Now, we could solve for that point and find it, but we're not going to do that right now. The main point of this lesson is identifying what kind of solutions are there. Is there one solution, no solution, infinite solutions? All right, so I hope this helps. It's a little bit of a longer video, but this is a very important concept.